Morning students, in our previous few lectures we have done with you relative atomic mass, gram atomic mass, relative molecular mass, gram molecular mass, and then we discussed equivalent weight or equivalent mass, which was something new for you. I told you atomic mass and molecular mass are not variable, whereas the equivalent mass is variable. Now, after completing the masses discussion, hopefully you must have understood this. We come to the discussion of a next topic, and today we start with the discussion of Avogadros law. Avogadros law. You are all familiar with this law, as the same has been done with you in the class 10th, Avogadros law. Now, what is Avogadros law? Recollect, rethink, try to recapitulate the class 10th, already being discussed with you. What is Avogadros law? Equal volume of all gases under same condition of temperature and pressure contains or always contains equal number of molecules. Recollect it, was discussed in 10th also. So what was the law? Equal volume of all gases. Equal volume of all gases under same condition of temperature and pressure. Under same conditions of temperature and pressure. Contains equal number of molecules. They contains equal number of molecules. Remember, we did this in the 10th also. So what does this law say? When the volume of a gases are same, they will contain the same number of molecules provided the temperature and pressure are same. What do I mean by this? Suppose we have got the two gases. This is hydrogen in the form of a gas. And then we have got hydrogen and nitrogen. Now I say we take equal volume. Suppose we take 1 liter of hydrogen and 1 liter of nitrogen. You can see over here their volumes are same. So if I say 1 liter of hydrogen has n molecule, here 1 liter of nitrogen will always also contain n molecule. Which law is followed? It will be Avogadros law. Am I clear? When the volume of our gases are same, then their number of molecules will also be same, provided the temperature and pressure does not change. Am I clear? Now, let me say there are two gases, X and another one is Y. If I say 100 cc of gas X occupies n molecule. Am I clear? What is the volume of X? 100 cubic centimeter. How many molecules are there? N. Now my question is, what volume will be, how many molecules will be present in 25 centimeter cube of gas Y. If there are two gases X and Y, we are given the volume of X as 100 cubic centimeter and it contains how many molecules? N. My question is, if the volume of Y is 25 cc, what number of molecules will be present of Y? I know through Avogadros law, if the volume is same, then number of molecules will also be same, provided the temperature and pressure does not change. Just see over here. Let me calculate the number of molecules of X for 25 cc. And then the volume will become same. So their number of molecules will also become same. So 100 cubic centimeter of X, 100 cc of X. It contains how many molecules? It contains N molecules. Fine. If I say 1, it will contain X, N by 100. If I say 25 cc, so how many molecules will be present? N upon 100 into 25. This will be equal to N by 4. Am I clear? So in this case, how many molecules will be present? N by 4. How do I know? I calculated the number of molecules present in 25 cc of X. Since in that case the volume becomes same, so number of molecules will also be same. So when the volumes are same, the number of molecules will also be same. So equal volume of all gases under same condition of temperature and pressure contain equal number of molecules. I think you must have understood. This was done with you in the class 10th also. Now application of Avogadros hypothesis or application of Avogadros law. Application of Avogadros law. Earlier it was called as hypothesis, so in some of the book it is also called as application of Avogadros hypothesis. First is it helps in determining the atomicity of a gas. First application is it helps in determining atomicity of the gas. It helps in determining the atomicity of gas. So what is the first application? It helps in determining the atomicity of a gas. What is atomicity? Number of atoms present in a molecule of a substance. Like if I say hydrogen, definition of atomicity must be clear to you. Number of atoms present in a molecule of a substance is called as the atomicity. Like if I say hydrogen, how many atoms over here? 2. So this is diatomic in nature. When I say oxygen, O2, here again it is diatomic in nature. So oxygen is also diatomic in nature. Then ozone. Ozone will be triatomic in nature. If you consider ozone gas, it is triatomic in nature. So first application of Avogadros law or Avogadros law is that it helps in determining the atomicity of a gas. As for example, if I say hydrogen when combines with chlorine, it will result in the formation of 2 molecules of HCl. Suppose here I say 1 volume, here again 1 volume. In this 1 volume, there are N molecules, here again N molecules. Because when the volumes are same, the number of molecules will be same. Suppose if I say there is 1 molecule, here again will be 1 molecule. As per this case over here it is 1 molecule. 1 molecule of hydrogen contain how many atoms? 2. One molecule of chlorine is containing how many atoms over here? 2. So from volume, we calculated molecules. From molecules, we come to know about the atoms. So indirectly, we calculate the number of atoms present in the hydrogen and the chlorine. And as I told you, hydrogen is a diatomic gas. So it helps in calculating the atomicity of a gas. Am I clear? Now the another application, which is very, very important. It helps in determining the relationship between vapor density and the molecular mass. So second will be, it stabilizes the relationship between molecular mass and vapor density. It stabilizes the relationship between molecular mass and vapor density. Molecular mass and vapor density. So it will stabilize and establish a relationship between the molecular mass and the vapor density. How does it establish a relationship between the molecular mass and the vapor density? Just see over here. We all know molecular mass will be equal to 2 into vapor density. This relationship will try to establish through Avogadros law. How? We know vapor density. What is vapor density? Define vapor density. It is the ratio of density of a certain volume of a gas to the density of same volume of hydrogen at the same temperature and pressure. Vapor density will be equal to density of certain volume of gas. Density of certain volume of gas to the density of same volume of hydrogen. Density of certain volume of gas to the density of same volume. Density of same volume of hydrogen. Density of same volume of hydrogen at same temperature and pressure. At same temperature and pressure. Am I clear? So what is vapor density? Density of certain volume of gas to the density of same volume of hydrogen at same temperature and pressure. Now what is density? Density is mass per unit volume. So this will be mass of a certain volume of a gas in a certain volume of gas to the mass of hydrogen in the same volume of a gas. Am I clear? So this will be equal to mass of a gas in certain volume to the mass of hydrogen in same volume. Am I clear? So mass of a gas in certain volume to the mass of a gas in a same volume. If I consider this mass of a gas in 22.4 liter and the mass of a gas hydrogen in 22.4 liter, then definitely we will be able to obtain the relationship. Mass of a gas in certain volume, let me say it to be 22.4 liter. Am I clear? So mass of hydrogen gas in same volume, let me say this volume is 22.4 liter. This is what? The molar volume. So this will become what? Molecular mass. And what will be the mass of hydrogen over here? 2. So formula relationship will be vapor density will be equal to molecular mass divided by 2. Is it established or not? So it helps in establishing a formula that vapor density will be equal to molecular mass divided by 2. Or we may say molecular mass will be equal to 2 into vapor density. So 2 applications of this we have done. Remember this formula. We will utilize this formula in a calculation of empirical and molecular formulas, which we did in the class 10th also. Fine. So what is Avogadros law? Equal volume of all gases under same condition of temperature and pressure contain equal number of molecules. What is the application of Avogadros law? It helps in determining the atomicity of a gas. Fine. It helps in stabilizing the relationship between the molecular mass and the vapor density. And what relationship is obtained? Vapor density will be equal to molecular mass divided by 2, or molecular mass will be equal to 2 into vapor density. What is vapor density? It is the ratio of the density of a certain volume of a gas to the density of same volume of hydrogen at same temperature and pressure. Third application. It helps in determining the molar volume. It helps in determining molar volume. Students, you have been studying since class 9th, I hope, and has been taught again and again that 1 mole of a gas at standard temperature pressure occupies the volume equal to 22.4 liter. So you have been studying this since class 9. Do you know this? 1 mole of any gas at standard temperature and pressure occupies volume is equal to 22.4 liter, or we may say 22,400 ml at standard temperature and pressure. Yes or no? Yes. And you all know this, that 1 mole of any gas at standard temperature pressure occupies volume equal to 22.4 liter. Have you ever thought from where have you obtained this relationship? Or just have we crammed this? I think we have crammed this. We must know that 1 mole of any gas occupies the volume equal to 22.4 liter, and from where do we obtain this relationship? This is an application of Avogadros law. How? Experimentally, we know that the density of a hydrogen gas is 0.00009 gram per ml. This is an experimental observation of a hydrogen gas. How do we know this? So we will try to obtain the relationship that 1 mole of a gas at standard temperature pressure occupies the volume, and this volume will be equal to 22.4 liter at the standard temperature and pressure. Remember, density of hydrogen, and believe me, this question was asked in, I hope in late 70s or in early 80s, and in early 80s in IIT. Prove that 1 mole of a gas occupies the volume equal to 22.4 liter. Nowadays, this entrance examination has become a damn easy examination. There was a time when it used to be a subjective paper for IIT, and really the concept in the subject was required. But now, a concept application in the MCQ form will do the work. Entrance are very easy, provided if you work in a very systematic manner. Density of hydrogen at normal temperature pressure. At that time we used to the word NTP. This is 0.00009 gram per ml. I am citing a experimental data over here. Experimentally measured density of hydrogen is what? 0.0009 gram per ml. Now from here you will find out that I will find out the volume occupied by 1 mole of a gas. Now density of hydrogen at NTP is this. It means 0.00009 gram of hydrogen at normal temperature pressure occupies what volume? Occupies 1 ml of volume. Am I clear? See this? 0.0009 gram per ml. It means in 1 milliliter, so much amount of so much mass of hydrogen is present. Now unitary method. If I say 1 gram of hydrogen, it will occupy what volume? It will be 1 upon 0.00009 ml of hydrogen. Am I clear? Now, what is the gram molecular mass of hydrogen? We discussed in the previous lecture. Exact mass will be equal to 2.016 gram. So 2.016 gram of hydrogen will occupy what mass? What volume? It will be 1 upon 0.00009 multiplied by 2.016, and it will come out to be equal to 22,400 ml, or we may say it to be 22.4 liter or 22.4 liter. Am I clear? So we have obtained the relationship that 1 mole of any gas at standard temperature pressure or at normal temperature pressure occupies what volume? It will be 22.4 liter at the standard temperature and pressure. Am I clear? Yes or no? So this is an application of Avogadros law. Here I have written NTP, you may write down STP also, no problem. Is it clear? Now, we have done with you in this chapter. We started with the definition of chemistry. We done the measurement and the precisions. We have done significant figures. We classified matter, did laws of chemical combination, certain numerical problems on that. Then we discussed masses, relative atomic mass, gram atomic mass, relative molecular mass, gram molecular mass, equivalent masses, which was something new for you. And then today we have discussed with you Avogadros law. What is Avogadros law? Equal volume of all gases under same condition of temperature and pressure contain equal number of molecules, along with the application of Avogadros law. Now we start with the discussion of mole. Mole we have studied in the class 10th also, so I'll just let you revise. You know everything about the mole. Mole. What do we mean by mole? Mole is represented by the symbol N. What is mole? Mole, if I define, it is defined as that number of atoms which are present in 12 gram of carbon 12. So mole, it is defined as the number of atoms present in 12 gram of a carbon 12. Number of atoms as in 12 gram of carbon 12. I think I shall be very clear. Number of atoms as in 12 gram of carbon 12 is called as a mole of a substance. How do we represent mole? N. How many atoms were present in 12 gram of carbon 12? Equal to Avogadros number. What was Avogadros number? Was represented by the symbol Na, and that number was 6.02 into 10 raised to power 23. This was Avogadros number. So any quantity of a substance that contain 6.02 into 10 raised to power 23 atom will be 1 mole. So if I develop a relationship, 1 mole of a substance, just see over here, 1 mole of substance, it can be 1 mole of substance. It will contain how many particles? As was present in the 12 gram of a carbon 12. And how much was that? 6.02 into 10 raised to power 23. So 1 mole of any substance, when I talk about 6.02 into 10 raised to power 23 particles. These particles will either be atoms, these will be molecules, or this will be ions. Am I clear? 1 mole of a substance contains same number of particles as were present in the 12 gram of a carbon 12. And how many particles were those? They may be atoms, they may be molecules, or they may be ions. These were 6.02 into 10 raised to power 23. Now, what is a gram molecular mass or a gram atomic mass? If I say gram atomic mass, mass of same number of atoms as were present in 12 gram of a carbon 12. And how many was those? 6.02 into 10 raised to power 23. So when I say 1 mole of substance which have so many particles, it will be having a mass, if in case of atom will be equal to gram atomic mass, in case of molecule it will be equal to gram molecular mass. What was gram atomic mass? Mass of 6.02 into 10 raised to power 23 atoms expressed in gram. Same was the molecular mass. So this will be equal to gram atomic mass. This will be equal to gram atomic mass of the substance, or this will be equal to the gram molecular mass of the substance. Gram atomic mass or the gram molecular mass of the substance. Am I clear? I must be. Is it clear or not? What is the definition of gram atomic mass? The mass of 6.02 into 10 raised to power 23 atoms expressed in gram. That was the case. Now, here it is the case. When I say gram atomic mass, it becomes a mass of how many atoms? 6.02 into 10 raised to power 23. When I say gram molecular mass, it becomes a mass of how many molecule? 6.02 into 10 raised to power 23 molecule. And this number represents what? 1 mole of a substance. So 1 mole of a substance will be having what mass? It is the atomic mass expressed in gram, that is a gram atomic mass, or the molecular mass expressed in gram, which will be a gram molecular mass. Now, I have just proved gram molecular mass of a gas occupy what volume? 22,400 ml or 22.4 liter. So, this will be occupying what volume? It will be equal to 22.4 liter at standard temperature and pressure, or 22,400 ml or 22,400 ml at standard temperature and pressure. Am I clear? Just check out. Gram molar volume is what? 22.4 liter. It's the volume of what amount of substance? Molecular mass or atomic mass expressed in gram. Molecular mass or atomic mass is the mass of what number of particle? 6.02 into 10 raised to power 23 particle. And 6.02 into 10 raised to power 23 particle represent how many mole? 1 mole of a substance. So here we obtain the relationship 1 mole of any substance. They contain how many particle? 6.02 into 10 raised to power 23 particle. It have what mass? Will be equal to gram atomic mass. Will occupy what volume? It will be equal to 22.4 liter at standard temperature and pressure. Now, these 4 words, if you can correlate, you can solve any numerical problem related to mole. Am I clear? Any numerical problem related to mole can be solved over here. As for example, now one more thing, if you want to find out the number of moles, if you want to find out the number of moles, it will be equal to given mass of the substance upon, in case of atomic mass, gram atomic mass of the substance, in case of molecular mass, it will be equal to the gram molecular mass of the substance. So, number of moles will be equal to given mass upon gram atomic mass, or number of moles of a substance, number of moles will be equal to given mass upon gram molecular mass of the substance. Upon gram molecular mass of the substance. I think I shall be clear over here. So how do we find out the number of mole? Given mass upon gram atomic mass in case of atoms. So this will be number of moles for atoms. In case of molecules, this will be given mass upon gram molecular mass of a substance. Am I clear? Did in the class 10th also. You must know how to solve the numerical problem. Suppose if I ask you, what is the mass of 6.02 into 10 raised to power, or suppose the question is, calculate the mass of 3.01 into 10 raised to power 23 molecules of oxygen. Molecules of oxygen. Now what is the gram molecular mass of oxygen? 32 gram. It is the mass of how many molecule? 6.02 into 10 raised to power 23 molecule. So how we will do it? 6.02 into 10 raised to power 23 molecules of oxygen will have what mass? It will be equal to 32 gram. How many molecules are given in the question? 3.01 into 10 raised to power 23. So how we will calculate? By unitary method, 3.01 into 10 raised to power 23 molecule will have what? This will be 32 divided by 6.01 into 10 raised to power 23 multiplied by 3.01 into 10 raised to power 23. If we cancel it up, it will come out to be equal to 60 gram. 16 gram. Is it clear or not? 6.02 into 10 raised to power 23 molecule have what mass? Equal to gram molecular mass. One will have what? 32 upon 6.02 into 10 raised to power 23. Mass of how many molecules is to be calculated? 3.01 into 10 raised to power 23. So 32 divided by 6.01 into 10 raised to power 23 multiplied by 3.01 into 10 raised to power 23. And this mass over here will come to be equal to 16 gram. Am I clear? So we may correlate these four terms. As for example, in this numerical, I have correlated this one. Now suppose the question is, what volume will be occupied by 3.01 into 10 raised to power 23 molecules of oxygen? Suppose the question is, calculate the volume occupied by, calculate the volume occupied by 3.01 into 10 raised to power 23 molecules of oxygen. Molecules of oxygen. Here I have to establish the relationship between the number of molecules and the volume. What relationship do I have? 6.02 into 10 raised to power 23 molecule occupy what volume? 22.4 liter at STP. So how will I solve this one? 6.02 into 10 raised to power 23 molecules occupies volume equal to, occupies volume is equal to 22.4 liter at STP. Am I getting clear? So one will occupy what? It will be 22.4 divided by 6.02 into 10 raised to power 23. Fine. How many molecules are there? 3.01 into 10 raised to power 23. 3.01 into 10 raised to power 23. It will occupy what volume? This will be equal to 22.4 upon 6.02 into 10 raised to power 23 multiplied by 3.01 into 10 raised to power 23. Cancelling up, it will be twice. It will be 11.2 liter. So what will be the answer coming over here? It will be equal to 11.2 liter. Yes? So from one information, other can be calculated. Now if I ask you, how many moles are present in 3.01 into 10 raised to power 23 molecules of oxygen? Suppose the question is calculate the number of moles in 3.01 into 10 raised to power 23 molecules of oxygen. How many molecules of oxygen are given? This much. What we have to do? We have to calculate the number of moles. So formula will be equal to given number of molecules divided, formula will be equal to, we have to find out the number of moles. So it will be equal to given number of moles is 3.01 into 10 raised to power 23 divided by 6.02 into 10 raised to power 23. So answer will be what? It will be 0.5 mole. What will be the answer in this case? It will be 0.5 mole. I think I shall be very, very clear. Is it clear? So, mole is the same number, that quantity which contains same number of particles as were present in 6.02 into 10 raised to power 23 as were present in 12 gram of a carbon 12. We have established 1 mole is equal to so many particles, it occupies so mass and have so volume. Hopefully, you have understood the mole. In our next lecture, we will try to solve certain problems of a mole and move further with a further discussion of this chapter. Thank you.